from the exercise. It says if f is a function which is from non-zero real numbers to non-zero real numbers and is defined as fx is equal to 1 over x, you have to show it is 1, 1 as well as onto. So R with this asterisk is denoting actually non-zero real numbers. So all real numbers except 0. You can understand why they have taken this kind of set. The reason being the function is defined as 1 over x. For x is equal to 0, the function will not be even defined. So if the domain and codomain both are denoting the non-zero real number, we have to show it is 1, 1 as well as onto. Then it has a second part which says if the domain is replaced by the set of natural numbers, will it be further 1, 1 and onto or not? So we'll check first part first. Okay, quickly recall the definition for 1, 1 function. We have to show that every distinct element in the domain has got distinct image. And if we are saying that there are two elements whose images are equal, then for the function to be 1, 1, the elements should also be equal. So keeping this in mind, we will proceed. Suppose x1 and x2 are two elements from the domain whose images are equal. So you can see we have already taken two elements with same image. And if the function has to be 1, 1, we need to prove these two elements which we have taken, they are actually also same. That is why the images are also same. That will make it 1, 1. So if I take two numbers, non-zero real numbers from the domain with the same image, that means fx1 is equal to fx2, then image of x1, fx1 using this definition can be written as 1 over x1, image of x2 can be written as 1 over x2. That means x1 became equal to x2. Hence the function is 1, 1. You can even proceed with it in this manner. If I take x1, x2, two elements of the domain with different images, if I put not equal to here, means there are two numbers with different images. So we'll have to show that the numbers are also different. Then also the function becomes 1, 1. So either ways you can proceed. For that, if you don't want to take images equally, put inequality here. If fx1 is not equal to fx2, that means 1 over x1 will not be equal to 1 over x2. Therefore, x1 will also not equal to x2. That means different elements having different images, and that makes the function 1, 1. So this is for 1, 1. Moving on to onto, we have to show every element in the codomain is an image. That can be shown by, it can be proved by showing that every element of this is related to some element in the domain for which it is the image. If we manage to do that, then it will become an onto function. So I have taken an arbitrary element y in the codomain which is image of some element. This is what we are assuming. And we have to justify that it is actually image of some element in the domain. So y is an arbitrary element such that y is equal to 1 over x. So by saying that this we are assuming that y is image of x. And what should be the nature of x? It has to be a non-zero real number. So only if this fulfilled, it will become an onto function. So y is an arbitrary element of codomain such that y is equal to 1 over x. That means x will be 1 over y. Nature of y is already known to us because we have taken it in the codomain. We have to show x, which is 1 over y, is also an element of the domain. So for you check the nature of x here. We know y is any real number other than 0. So if y can be replaced by any real number other than 0, what will be the nature of x? It will also be any real number other than 0. So what is domain? Domain is also the set of real numbers other than 0. So we can say for every y which belongs to the codomain, there exists an x which belongs to the domain. That means every element of codomain is image of some element in the domain. So the function therefore becomes onto. So if domain is non-zero real numbers, then this function is coming out to be 1, 1 and onto. Now let us change the domain by set of natural number. Say the mapping is from the set of natural numbers to non-zero real number. Quickly checking for whether it is 1, 1 or not in the same manner. Suppose the only difference is this time x1 and x2 are natural numbers. So let x1 and x2 belong to the set n. such that fx1 is equal to fx2. That will imply 1 over x1 is 1 over x2, which further tells us x1 is equal to x2, hence making the function 1, 1. Now checking for onto function, say y is any arbitrary element in codomain. Codomain is still the same, non-zero real number, such that y is equal to 1 over x. Then x becomes 1 over y. Now, as I told you earlier, the nature of y is known to us. But we have to see for that y, is x an element of the domain or not. Over here, both codomain and domain were non-zero real number, and we could justify that for every non-zero real number y, x will also be a non-zero real number. Here you have to show for every non-zero real number y, x should be a natural number. Only if it happens, then it is an onto function, otherwise not. If you see, you quickly take one example of y. See, let y is 2. This is a non-zero real number, is it or not? It belongs to the set of real number. Then what will be x? X will be 1 by 2. Now look at this. This does not belongs to the set of natural numbers. So there are many non-zero real numbers in the codomain which are not images of any real number. So if that, not image of any natural number. So if that is happening, that means this set is not in, this function is not an onto function. In this case, the codomain will not be equal to the range of f. You can quickly understand what type of mapping it is. Here we have natural numbers and here we have non-zero real numbers. So I will have numbers like 1, 2, 3, 4, 5 and so on here. And what will be their images? 1 will have image 1, 2 will have image 1 by 2, 3 will have image 1 by 3 and so on. Each natural number will have some image. So these numbers are having images. But simply look at this number 2. 2 is not image of any element in the domain if you see. So what we could show? We could show that as for all y belonging to non-zero real number, x does not belongs to n. Therefore, f is not onto. So you can see by making a slight change in the mapping, the function satisfies few things and does not satisfies the remaining.